So it's 2 o'clock. We start with the project presentations. We limit the presentations for 3 minutes. So this will be the first presentation by, I forgot the name of the group. Let's see. One moment. All right, I only see it when I select it. The CMAP Hackathon presentation, is that, can they come forward? Or is it remote?
Is a remote presentation.
All right. This from you, Logan. Okay. So
No, not
right.
not from me. We are doing PQC. It's later.
Okay. Thanks. So CMAP presentation. There are a lot of slides, so I really like to keep it within the 3 minutes. And the presentation afterwards is the BGP LS extensions, so they can get ready for the presentation afterwards. Okay. Okay, please go ahead. I can give you right. One moment. So you can now forward the slides yourself.
Yeah, perfect. Thank you.
Yeah. Okay.
Yeah.
Okay, please go ahead. Thanks.
Hello, everybody. My name is Vivek. I'm working on CMAP, known before as Digital Map. Last hackathon, we work on ISIS and we add some prototype for adding external reference to CMAP. And for this hackathon, we focus and we continue to explore some option for adding external reference. And also we start modeling SRv6 over the ISIS one. And we work using the SRv6 lab from Swisscom. First, I'm just going to talk about external references. We explore two approaches. First one, we add some external container directly under the CMAP base model. And the approach two is the same, but we do it externally and independently of the CMAP. So first step is we create some template. What we call a template is just how we can get some information. The how can be the protocol, for example, based on YONG, RESTconf or netconf, or for some historical data, for example, SQL. So we can have many protocols as we want. And for the information can be in configuration, metric or state. So this is the first step, the template creation. And when we have the template in the approach one, then we are just building the CMAP and we add all the external relation we need. Below, we can see an example with one multi-point termination point linked to the same template. And since each termination point is different, we keep the specific parameter in the relation so that we can retrieve the correct information. In approach two, first step remains the same. We create the template, then we build the CMAP as the way we used before. And when we have the CMAP, we can now create a relation in another data store that we do the link between the CMAP instance and the template. So here we have a relation with a TP-ref that link to the CMAP instance and some parameter like before, like in approach one. Also, we start modeling SRv6. So we add this on top of ISIS. We create some new entities in our database. So we have SRv6 network, SRv6 node, and also SRv6 source. And we use like the supporting relation entities from the base model to show how ISIS support SRv6. And this is a big view of what we did in our database for the approach one. We have SRv6 on top of ISIS as some template link to the termination point. And this is how it looks like, all the relation between each entities. So what we achieved, we developed some library to manage external references for external element, and we started adding support for CMAP for SRv6. And what next? We continue explore some approach and link to other domains like inventory or VPN service, and we continue our modeling for SRv6. Thank you.
Thank you very much, and thank you for, well, keeping in the time slot. Excellent, thanks. All right, next slides. Okay, one moment, please. Yep, sorry. So the next one is BGP-LS, and after that is the traffic steering using BCP flow type, or BGP. Yep, thank you. You're welcome. Yeah, you can use. Yeah? Okay. Thank you.
Hi, our theme is BGP-LS extensions for SRv6 service training. Our objective is comprehensive management for SRv6 SFC using a controller. So we implement the BGP-LS extension for SRv6 SFC for our SRv6 SFC architecture. This is a link of our target draft. Our hackathon goal is implement TLBs to OSS BGP daemons, and we implement Wireshark detectors, and we doing the interoperability testing. This is our architecture of SRv6 SFC, and we implemented the BGP-LS extensions for acquiring service segments. This is the architecture. This is the new two TLBs. First is service training TLB, and second is OPEC metadata TLBs. These are our implementations. First, we implemented these TLBs for GoBGP and XBGP. And next, we implemented the Wireshark dissector for these TLBs. And we send it our PCE. We sent the BGP-LS service segment implementation from EXA and Go to EXA and Go, and we captured our packet to using Wireshark. This is the result. We succeeded implement SCTLB and OMTLB. We completed this implementation. This is our member. Thank you. Next presentation is me.
All right, excellent. Great. It's very efficient. So the traffic steering, yeah. And after the this presentation, or the next presentation, there will be verifiable routing origins. Here we go. Yep, okay.
Thank you. Next theme is traffic steering using BGP flow spec with SR policy. The background is the same. we want to management SR-Physics network comprehensively. So, well, our objective is manage SR policies, including the SFC chain from PCE and enabling SR policy selection on a path flow basis. So our goal is implement BGPLS extension in GoBGP and implement PSEP, FilterNet, full cover electronic virtual routers, and Polar PC. This is same architecture. And we implemented the BGP flow spec with SR policy and new TLB for PSEP, color TLB. These are our implementation. We implemented GoBGP to BGP flow spec extension. And we implemented a new PSEP extension, color TLB for VFX and Polar PCE. And also we implemented Wireshark dissectors. This is PSEP and this is BGP flow spec. We complemented all of our implementation. And this is my team members. Thank you.
Okay, thank you very much. Up next is the presentation of traffic steering. And after that, there's the, oh no, sorry. So we just had traffic steering. So up next is verifiable routing. And after that is exchanging inter-domain routing. Yeah. There we go. Yeah, you can use these keys. Yeah. Okay.
Hello everyone. This is VRO project, verifiable routing always where AS cooperations. I'm Shenglin Jiang. To solve the prefix hijacking, some solutions were introduced, but this system faces the challenges in distinguishing legitimate malicious and malicious attacks. So the hackathon aims to design a verifiable cooperative system among AS code VRO to enhance the trustworthiness of the routing array. The VRO system consists of the allow list, the block list, and the fusion of the multiple sources. The allow list enable AS to send the same prefix using aggregate signatures. On the other hand, the block list allows AS to vote on the prefix origin conflicts based on the local information. This is our team, our code space, and our IETF drafts inside of the. That's all for our presentation. Thank you very much.
Thank you. Hi. So, sorry. Up next is the enhancing inter-domain routing, and after that is the post-quantum crypto, DNSSEC. Yeah. You can use.
Okay, thank you. Hello, I'm Yang Guo. Today, my topic is about enhancing inter-domain routing security with forwarding commitment-based BGP, or in operation FCBGP. Our hackathon plan is about implement. Is about implement the forwarding commitment-based BGP. Here is some documents about FCBGP. The first one is our paper. The second one is the framework of forwarding commitment-based BGP. And the third one is the protocol specification. So we only focus on the protocol specification. So in that hackathon, we want to implement FCBP with FR routing. And here is the FCBP overview. It combines the control plane and the data plane to solve the BGP security problem. It can be separated into several functionalities, including the FC announcement and the generation and the BGP validation, and announce the binding relationship to the previous hops, and validate the traffic in forwarding plane. So we have implemented the FR routing, the FCBP with FR routing, and implement F server in Ubuntu 2020. But we haven't found a home for our drafts. We will present FCBP in IDR at Monday. If you want to learn more about FCBP, you can have a look. Thanks. And here lists our team members and the documents our FCBP. Thank you.
Thank you. So there we go. Next up is the post-quantum DNSSEC. And after that, it's the interface to in-network computing. I think it's half of the title. There we go. Joe, please go ahead. So we set a timer to 4 minutes. For the presentation.
All right, thank you. All right, so we were looking at PQ DNSSEC metrics with MTL mode. Just a little background on this. There's a draft spec about how to use MTL mode with DNSSEC, and then we have some open source implementations that we are working with. The new one on here for this time is MTL and LDNS. So we've open sourced a update to LDNS in our repo here that allows you to sign with the NIST algorithms and with the MTL mode algorithm that we have been talking about the last couple of IETF meetings. So what did we do? Well, this time for 122, we signed some zones with the different keys, and then we hosted them on an authoritative service and ran various queries to measure the response times and compare and contrast them, especially across different networks, since this location is different than some of the other places we're running them. We can kind of see what the network impacts were versus the zone specific impacts. So this is the setup. We had test clients. They were using an MTU of 1232 bytes, and they were querying to an authoritative server. And so what do we learn? A couple things. The first thing is the query response times. We noticed that the TCP times for round trip query response were about double the UDP response times. So, DNS runs a lot over UDP, some over TCP, and there's definitely some reasons why those things remain important. Additionally, we noted that the MTL condensed signatures worked very well over UDP, even over the long distances, and let us not truncate responses and have to do retries, which is a nice benefit as well. So we got some good findings here. We definitely have a lot of other things still to do. So a special thanks to Caspar and Wateroo for helping us out, joining us at the hackathon, and helping collect this data from different data points. And the final point here is next steps. The PQ DNSSEC meeting is on Tuesday, side meeting in meeting room 2 from 9:30 to 10:30. So if you find this interesting or want to learn more, come join us, because there'll be a lot more things about metrics and all there. Thank you.
Right. So next is the interface to in-network computing. And after that, we'll have the presentation of ICMP error message authentication. There we go.
Oh, hello, nice to meet you all. My name is Yosef An from the Sungkyunkwan University in Korea, and I'm going to talk about the interface to in-network computing function ICE to ICA project. And our project champion is Professor Jeon Jung. And this is poster for our project, and you can check the architecture or object future work detail about it. And our Hackathon project's goal is to show the facilitability of intent translation in interface to in-network computing function and its framework. And also you can see the detail about internet draft for I2ICA project in this page. And this is the architecture for our project. As you can see, there's two parts, and one is the edge system, and the other part is the mobile object part. And it can start from the user part, and user give the intent to the controller part. And controller, inside the controller, there's a intent translator, and the translator can make some network policy and application policy. And after that, the controller give that policy to the mobile object like the car or drone through the Kubernetes. So after it, also after that, those kind of after mobile object given the policy, it can change the configuration inside the drone or car. And after it changes, you have to check if it is the working well inside the mobile object. So the mobile object give the monitoring data to the analyzer for the report form. So after it give the monitoring report to the analyzer save the monitoring data in the database. And this is the follow diagram for our intent translator. And the left part is the, as I told you in the previous page, and the right side is the more speaking of intent translator, and is extract the attributes from the high level JSON intent, and it translate the JSON intent into the YAML intent, and after that, it transmit the YAML intent to I2ICF controller. And what we've learned is that we implemented the intent translator for I2ICA framework for mobile objects. And we also demonstrated the intent-based network IBN for the configuration and monitoring of mobile objects. And this is the demonstration of I2ICA framework. So we made each part of the architecture as a service using the Kubernetes. As you can see, there's a user, controller, analyzer, and monitoring analyzer, and mobile object. And you can see the log of each of the service. And this is the demonstration of the intent translator. And you can check the open source for our project. And this is the YouTube video. And the next step, we experienced the implementation and design of intent translator for I2ICF. So for the next IETF, we'll develop on intent translator advanced version using the AI-based scheme on the Kubernetes. And also we'll design young data model for the main I2ICF interface. This is our hackathon team, and this is a list of our project member. Thank you very much.
So running up these three-step stairs keep me in shape. Next is the ICP error messaging or message authentication, and after that we will have the validate configuration subscriptions presentation. There you go. Yeah. You can use just the arrows.
Oh, okay.
Yeah.
Okay. Hello, everyone. Today we introduce the ICMP error messaging authentication using challenging conform mechanism. Firstly, the ICMP error messages are important and prevent the feedback about the IP network communication problems. However, the current SMP specifications have inherent limitations that allow all pass attackers to spoof SMP error messages. And the attackers can leverage SMP error messages for different attacks. And so we plan to design and implement a challenging conform mechanism to solve it. And we have preferred two SMP based attacks, and we realized challenging conform mechanisms by using NetFlatter hooks. What's more, we have prepared two drafts of our challenging conform mechanism, which will be present tomorrow. That's all. Thank you very much.
Okay. All right. Next is the validate configured subscription, and after that is the post-quantum crypto open source software presentation. Up to you. And yeah, you can use, this is most convenient, I think.
Okay, perfect. Hello, everybody. Yeah, we did again the configured subscription Yang push publisher implementation validation. And this time we were focusing mainly on the capabilities discovery, on the notification envelope. And what's also pretty new was that this time we not only had routers, but also OLTs. So we are now also on the broadband access side. This is our new website, which we just developed. This is the repository where you find all the test results, the packet captures, and also the transformations. The documents tie into the so-called Yang push to Apache Kafka integration architecture, and the yellow highlighted ones are the ones we are focusing in these test results. So on Cisco iOS XR, the notif envelope and in the subscription started notification, I highlighted here in yellow. Here, the RPC call for discovering the transport capabilities for configured subscriptions. Here, some notifications on subscription started, and also some initial notifications on Syncon start from the OLT implementation. Here, how we can discover in the capabilities which XPaths are being supported in which granularity. Some other implementation on virtual PE nodes on 6Win side with the notif envelope. And the first time we have now not only JSON encoding, we have also CBOR encoding with named identifiers. This is how it looks in Wireshark. And this is the summary results from the 4 implementations which we validated towards these documents. Green the new features compared to the previous hackathon. On MVP 1, this is now on MVP 2. So we have the first CBOR implementation, and also we are moving slowly towards the capabilities discovery as well. This is the hackathon team. Thanks a lot. Was a lot of fun here. Thanks.
Thank you. So we just want to make sure that we don't miss any presentations. So if you submit it, and you can also check on the data tracker if your presentation is on the materials. If not, please resubmit or contact Charles or walk over to us. So we want to make sure we don't miss any presentations. Okay, the next presentation is the post-quantum crypto open source implementation.
Yes.
Oh, okay, excellent. And after that is the evaluating of the performance of. So this is the next presentation. Good. I will hand over. Well, sorry.
Benno, can you help with switching over slides?
Yeah. Oh, okay. Right. So I think. All right. I skipped one. So okay, here we go. And Logan, here's control.
Oh, thank you very much. Thank you very much. So our plan during this hackathon was actually working on PQC for open source software. So when we initially started looking from PQC from Africa, we realized that Wireshark, Nmap, and Zmap didn't quite support it yet, like we couldn't decode it on the wire. So before we started looking at TLS libraries such as GNU TLS, we realized that the tools that we use for network analysis and auditing, even software like SSH Audit, they didn't support post-quantum key exchangers. So there were two drafts, the one for MLChem and the one as MLChem with standalone. So we work on implementing that. So for Nmap, it was 3 PRs that were submitted. One of them was merged. For Zmap, 2 PRs. Both one was already merged, and then from SSH Audit, 1 PR. For Wireshark, it's an interesting story, is that there was this discussion about whether to have MLChem in the ordering before and then have 25519 after. So what we did was changing this in Wireshark, and then as the discussion moved forward, we switched it back to X25519 MLChem 768 for key exchangers. So basically all the tools that are open source and people, a lot of developers, system admins and auditors rely upon, Nmap, Zmap, Wireshark, SSH Audit, they can now read post-quantum key exchangers that have been more or less approved within the IETF. Okay, so the big thing that we work on was GNU TLS. We implemented MLChem 1024 and P384 in hybrid mode. So that was quite an interesting challenge. So the lesson that we learned from this is that there were a bunch of regressions that happened with GNU TLS, and we had to make sure that we were interoperable with OpenSSL. And thanks for the OpenSSL team for getting MLChem within that specific branch. So we were able to test this and identify regressions. And it was quite a bit of challenge because we weren't immediately familiar with GNU TLS internal. So it took us some time. And we were working with LibOQS from PQCA project. So we've got quite a bunch of team here. Kavish, Jay Kishan, myself, Kushal, Pushan, Atish, and Jagvir. And didn't show up in the slide, but Benson Muite, who is actually remote as well, he's from Kenya. He actually helped with Nmap. So this is just the beginning. There are a bunch of integration work that needs to happen in a couple of open source projects, and we are working on that as well. And again, thank you very much for taking the time to listen to our presentation.
Thank you very much, Logan. So the next presentation is the, let's see, evaluating the performance of different DNS server. Here in the room, excellent. And then the next one after that is validated configuration. No, sorry, on the use of Young provenance. Is that correct? Yeah, okay. There we go.
Hello, everyone. So I'll be talking about PDM implementation and benchmarking of different DNS measurement, different DNS implementations. So in India, we have our own internet measurement network called IMN, and it has over 100 nodes all over the country. And in that IMN, we have implemented the PDM protocol, which is an extension header of IPv6. So what we did here was we implemented IPv6 PDM protocol during DNS measurements, and we created a testbed in testprotocol.in where there were some servers in Mumbai and some servers in Singapore, and then we benchmarked them. So this is the image of the nodes that are there in the country, how they are distributed. What got done? So we implemented the PDM protocol in both as Linux modules and eBPF, and we also implemented the client as a SCAPI contribution, and also we created a dedicated Python package for DNS measurements. So our IMN is now PDM compliant. We have set up the test bed, which is entirely IPv6 enabled because extension headers otherwise do a hell lot of packet loss. Got more visible analytics on DNS servers performance. So this is a test bed. In the Mumbai side, there was NS2 that was PDM enabled using Power DNS, and in Singapore we have NS3 as Power DNS and NS4 as bind. This is the network latency graph that we get. So Mumbai to Mumbai network latency, that's represented by blue, is like shows a very little latency, network latency, whereas Mumbai to Singapore node shows a route shows like big spikes on network latency because of the distance. We also noticed that when we are comparing Power DNS with against bind, especially when there is not a hell lot of traffic, what we get is that bind like there is a teeny tiny performance optimization in bind because there's not a lot of function calls probably getting in. So probably if we do a DOS attack, probably Power DNS will outperform bind. But in this case, when there is not a lot of DNS packets, bind gives slightly better results. So there's a dashboard here that in real time shows the performance of both network and servers of these DNS servers, NS2, NS3, and NS4 for testprotocol.in. That's it. These are all the team members that contributed in this project, and that's all. Thank you, everyone.
Okay, thanks. Next up is the young provenance. Right. There he is. And after that, there will be the, oh, this double. Extending key updates in TLS 1.3. But first, the use of young provenance. Okay. You're welcome. You can use arrows, whatever.
Very good. So basically, the idea of this project was to bring a reference implementation we have started to work on based on or oriented to this provenance idea that we started some time ago. For provenance, what we want to guarantee is the origin of young datasets whenever those young datasets are going to be reused or reapplied or used for as an evidence for whatever the purpose. And typically in these days, for example, AIM or training or inference, the idea is to being able of verifying where the data come from and being able to guarantee that has been not altered, modified, etc. These are the related to the drafts. Originally was the idea appeared during a discussion for this draft on metadata manifest for Jan datasets. From this, we started to elaborate and build the provenance idea. The provenance is supported by using or inserting cozy signatures inside different Jan elements, using 4 different what we call enclosing methods depending on the nature of the Jan fragment. What we have brought is a complete reference implementation of what is proposed in the draft that is able to assign and verifying both JSON and XML serialization formats, while we are now still working on the seaboard one. We have brought a set of microservices to demonstrate and see the integration with different JAG models. We have made exercise these signature and verification mechanisms with a number of JAG fragments of different sizes, schemas, and encoding for sure. And well, the code is now available in GitHub, and if the images that were used for the microservices are available as well in Docker Hub. And well, what is planned next is from the experience we have gained here and preparing the demo and executing and exercising the different modules is to work in enhancing the design in terms of the core cozy libraries, how enclosing methods are implemented, how the interfacing is performed, and some issues with canonicalizing the contents for verification and signature. And the idea is to make this design better integrable with other Jan elements. Like, for example, while Thomas was talking about this PubSub, the idea is to have a publisher and a consumer that is attachable to the bus that they're working with. And well, the idea is to demonstrate this in Madrid, so stay tuned, and in a few months we will have this for you to play with. Thank you.
Hi. Excellent. Yeah. Here, yeah. And after this presentation, a Python proof of concept implementation of, etc. Something. Thank you. Thank you for doing it.
Do I move forward the slides?
Yeah.
Okay.
You can do the slide. Yeah. There you go. Thanks.
Okay. Hi, everyone. In our team, we worked on an implementation of the extended key update. So what is that? The problem is that TLS 1.3 doesn't provide forward secrecy for the post-handshake key update, which means that an attacker who is able to do a static key exfiltration, for example, obtaining the session keys, can then later on decrypt the entire session. So what did we do? The fairly obvious, we added forward secrecy as it is available in some other protocols like iQuestion 2 and so on, or Signal. And that forces an attacker to do dynamic key exfiltration as explained in this RFC 7624. And you see that draft over there as well. So how does this extension work? Obviously, it has to add a few new messages. So there are 4 messages. 2 of them, the first 2, exchange the public keys or the chem public keys if you use chems. And then the last 2 messages just responsible for activating and switching to the new keys. So pretty simple. So what did we manage to get done during these 2 days? So we implemented the exchange and obviously the logic around it. What we didn't manage to get to is to work on the PQC part. So that was maybe a little bit too ambitious. Yeah. We also fixed a few bugs. So there's some PRs available, and there's also the PR with the code. We used embed DLS for the implementation. I think that's on the next slide. And here's the team, a small picture, and thank you all.
So up next, the proof of concept implementation, or the Python proof of concept implementation. Is that in the room? Excellent. And after that, we will have integration of DNS over co-op. All right. You can use the arrows. Yep.
Okay, thank you very much. Sorry for that. I forgot to modify the title. I'm Yuchen Wang from Ant Group, and I want to present our hackathon plan about the implementation of ECDH VI size mathematical logic with Python. And here is our proposal, which we think may be of interest to the PPM work group. And the PSI, what is PSI? PSI stands for private site intersection, where two parties with two sites can calculate the intersection without revealing the records that are not in the intersection, where two parties with secret key SKA and SKB can use the secret keys to mask the original record as shown by the figure, which is very similar to the classical Diffie-Hellman key exchange. And the main logic of this protocol is that one has to compute, one has to map a string of binary lengths to elliptic curve points, 2 points on the elliptic curves, and use the private keys to mask the point. So our plan is to follow the first step is we want to find a standard implementation of RFC document of hash to curve, which is proposed by the CFRG, and then use the standard Python library of elliptic curves to multiplication. And we did implement a proof of concept of our protocol with Python, which CFRG draft a proof of concept of hash to curve, and also use Python's ECDSA and the hash libraries. And you can find the implementation in the following link. You have to, if you want to run it, you have to run with the CFRG's repository together. What we learned, what we learned is the first one that we found that currently there is no standard implementation of the RFC primitive that we employed in this proposal, and that we only in Python there's there's indeed implementation in other languages such as Go, and we only in Python we only find a proof of concept on the draft, and we think that maybe the community should focus on the implementation of CFRG's RFCs and their suggested primitives, and this because these algorithms and the primitives may be furthermore referred to by other RFCs and drafts and implementations. And the second lesson we learned is that AI only provides limited support for crypto implementations because I'm not very familiar with Python. So I asked to AI to help me in Python, but I also found that AI is not able to produce secure and correct codes for cryptography usage. And that is the lessons we learned. Our team members include me and my colleague Wenting Chang, and this is the first time for us to participate with IETF Hackathon. We will also hold a set meeting for privacy preserving computation with cryptography in Tuesday afternoon, and you are welcome to participate with us. And here are the links. That is all. Thank you very much.
Okay, so up next, Martin. And then we have the ILNP presentation after. The list becomes longer and longer, so difficult to find. There we are.
Is it the newest version?
This is the latest version. Can you check? You see the pre.
No.
No.
It's,
Let's see if I can find the latest version.
I think it was directly below.
Okay. This one. Yeah. All right. Oh, it's also mentions revision 1, so that's good. Okay, there you go.
Okay, hi, I'm Martin, and I tried to integrate DNS over co-op, for which there's an existing draft, into various DNS implementations. So first of all, there is a DNS over co-op port for Unbound, and which was the main goal of this hackathon. And then there were some secondary goals to provide Linux distribution code for DigDoc, for the DigDoc doc client, and port DNS over co-op for the not DNS server. Sadly, as far as I know, there are no contributors for that present, so this was off the table for now. If I'm wrong, please come forward. And yeah, the code was mostly written by students from TU Dresden, so my job was just to integrate it with existing platforms. And for Unbound, there was first the job to rebase the codes to the current master, clean up the code of debug printfs and some IDE stuff, write tests, provide compile time checks for that when libcoop is in there, and also clean up the code conceptually. And for DigDoc, it was basically just tag the release and then provide a Fedora package. And oh, there are supposed to be some hooks there, but apparently it's not parsed by the meet echo. You can see that in the data tracker then. But yeah, basically we got the rebase done and a little bit of the cleanup, but we didn't write any tests yet and provide compile time checks and so on. So there is still some work to do there. For DigDoc, we did all the tasks we wanted to do. So hopefully, once it's reviewed by the Fedora community, there will be a Fedora package for DigDoc. And what we learned is basically that bringing new protocols to existing software is hard, because some communities are resistant to introduce dependencies, but especially when you have something like co-op, where you have also OSCORE with it, reinventing the wheel doesn't make that much sense. So you want to maybe use something like libcoop or something else, but some, not Unbound, but some other implementations were a little bit resistant against this. And if you have these dependencies, you should try to keep it to the distro libraries version and not use the current development version, because we had with DigDoc the case that when we had with DigDoc the case that there was a bug in libcoop, which wasn't fixed in the current release yet, and so there needed to be a very hurtful workaround. But yeah, in the end, we didn't manage to get, of course, the libcoop community to update the distribution package, because it's also not the job. But okay, anyways, use the distro version. So, and to wrap up, yeah, these are the team members. I also listed the students, so they aren't technically participants, so I didn't list them as first-time participants. And yeah, the goal for the week then for me is to open a PR at the end of the week. If you are a Debian maintainer or Ubuntu maintainer, please talk to us regarding the DigDoc client. And if you are a not DNS maintainer, please come to us as well, because we still want to integrate this. Thank you.
All right. So next is the ILNP presentation. It's over here. And after that is VCon. Yeah.
Okay, so ILNP is the Identifier Locator Network Protocol. what we've been up to so far over the last few IETF meetings is refining a implementation that we have in FreeBSD 14 to make it work better and make it easier to deploy. Just as a reminder, what is ILNP? What is it trying to do? It's trying to change the addressing architecture used in IPv6 to make some gains in things like multi-homing, multipath capability, mobility, privacy, and security. And the challenge is to do that without breaking the network and without breaking the application. So having existing applications still work as they do. So in the hackathon on this particular meeting, we had 3 of us here, Rod, Alistair, and myself. A special thanks to the NOC team, especially Con and Sean for setting us up with a V6 prefix and having very smooth connectivity for us. The aim for us in this particular meeting was to improve the deployability of what we have and also see if it will work with the latest 14.1 release FreeBSD kernel. So test the basic connectivity and improve the deployment capability that we have. So what did we get done? Well, there was some heavy lifting by Rod on FreeBSD debugging, and so that now is mostly done, and we have a deployable system. We can deploy something very easily now from a baseline FreeBSD 14.0 or 14.1 installation, and we have some nice connectivity tests between here and the University of St Andrews, where I work in Scotland. So we have ping, of course, working, but we have SSH and rsync working, so TCP works, which is great. And we're just currently doing some IPERF 3 tests to see how the performance is. The connectivity between, the basic connectivity between here and Scotland isn't so great, so I'm not sure how those tests will proceed, but at least we have TCP working, and we're also trying to get some dynamic multipath working at the network level so that existing transport protocols can use multipath without being modified themselves. Also, we've got another test bed in progress in Fremont that Rod is working on again to show that it is deployable, and that's going to be interesting because that's not going to be on real machines, that's going to be virtual machines, and if that works, that will also help with deployability. Also, please do come and talk to us at the Hack Demo Happy Hour, and we'll be around all week, as well as in the Hack Demo Happy Hour in the shared workspace. Thank you very much.
So up next is Dan over here. And then after that, we have the ultra low crypto. Let's see, is that correct? Here's Vcon. Yeah, and after that, the ultra low latency crypto algorithm. Yeah. There we go. Let's go. Oh, after this presentation. Sorry. Apologies.
Hi, my name is Dan Petrie, and we were working on VCon. VCon is a standard for containing conversational data, right? Things like email threads, phone calls, video conferencing, so forth. We had a couple things that that we're focusing on at this hackathon. First of all, the draft we just released had a couple small upward compatibility issues, or created a couple upward incompatibility issues, and then we have two kind of ambiguities in the draft that relate to appended, which is this concept of, you know, you've got a VCon that's signed, so you can't modify it. So you want to create a new VCon that you can append additional data onto. And then the other kind of ambiguous or deficiency in it's not wasn't tested or well specified was in the situation where you may have a video or audio or video conference, and you create a separate recording for each party in that call. So you have these multiple recordings, as opposed to, you know, one mono channel recording, or one multi-channel recording. And so that was something, an issue that was identified that we wanted to explore and kind of work out. So we did more kind of design thought than coding in this hackathon. And so the participants, we had you can see them here, and what did we get done? Well, we tested some code that proved that we could do migrate over the upward incompatibility because we had some parameter name changes, and we did some exploration on approaches for doing appended, doing a deep copy versus a incremental content change, and then placeholders or references to the original vcon. And then we explored two ways to go with the multiple recording for a conference, where we have in a single dialogue you can have an array of recordings, whereas currently we can just have one, versus we just have multiple dialogues with one recording each, and then the time sequences of those can be used to indicate that those are overlapping recordings. So that's what we worked on. The repo, you can go to GitHub, and there's a Python library for constructing and doing stuff with vcons. There's a command line interface, so you can do stuff on the command line with vcons. And there's this workflow integration platform for doing AI-based workflows with using vcons and doing analysis on your conversations. Have a look.
Up next is the ultra-low latency cryptography, and then we have, right, it's here. Yep. And then the Lake project after this presentation. Yeah, you're welcome. You can just use that.
Okay. Hi, everyone. I'm Yumi Sakemi from GMO Cybersecurity by ELI Japan. Today, I will talk about activity of ultra-low latency crypto Arayon. First, I explain about the overview of Arayon. Arayon is a secure and low latency cryptographic permutation. It is based on AES instructions such as AES-NI, and it can be applied to encryption and hashing. If you want to know about Arayon, please refer the IETF 117 hackathon slides and our internet draft. As a use case of Arayon, we expected that the Arayon can be useful for the real-time secure communication such as esports, remote surgery, and satellite communication. Throughout our activities, we experimentally found that the Arayon is faster than current cryptography, such as AES-256 GCM and SHA-256 under these conditions. This slide showed our hackathon plan at IETF 122. Throughout our activities, we received some inquiries, the impact of Arayon in IPsec from other IETF participants. So in this hackathon, we try to apply Arayon to IPsec by using DPDK crypto library. As a result, we successfully apply Arayon to DPDK implementation, and we verified the Arayon operation by test program in DPDK. But we did not check the performance, so this is our future work. And finally, this slide shows the summary of activities. Throughout our activities, we had prepared the following some codes related to Arayon, so please feel free to write them out. That's all. Thank you for your attention.
Thank you. So up the lake projects, and that's a combined presentation? Yeah, excellent. So you reserve 5 minutes for the combined presentation. That's fine? Okay, excellent. And after the lake project presentation, there will be the upper P presentation over there. Yep. Here's the lake project. Here we go. Please go ahead.
So, hello everyone. My name is Giovanni Federcheski. I am with INRIA in France, and I will present 3 projects ad hoc in robotic swarms, ad hoc with swarm attestation, and a cryptographic abstraction layer for Rust, so that we can run ad hoc in more devices with the memory safety. So, to begin, some context. So, we have a project that is to build a testbed with 1,000 micro robots. So, the robots look like that, like you can see, and they're very small. So we'll have a lot of them, and we want them to be secure. And this is actually a very interesting case, so that we can really stress our protocols. So we developed a custom link layer protocol that we call Blink, that is basically Bluetooth Low Energy, but only the physical layer. And then we developed the link layer custom link layer using time synchronized channel hopping. And we also allow handover very fast for the robots. And we want to use ad hoc to use in the join procedure to authenticate in this new network. So we have the implementation of this network called Blink on open source, and the implementation of ad hoc, which is Lakers in Rust, also open source. And the Lakers implementation has a C wrapper, so we can call it from C projects. So the goal is to integrate Lakers in Blink, this network for the robots, and to authenticate the network join. So here is what we achieved. So basically, we could integrate Lakers in Blink, so that works. The device can generate a new message, and the network join is still on progress. We were able to generate and transmit the first message, but then we were not receiving it. I think it's a synchronization problem, but I don't have a logical analyzer here. So going back, I'll be able to find out what's going on. And the next one is basically a discussion, several discussions we had about remote attestation with ad hoc in swarms. So basically, the idea of attestation is to verify that the firmware in these devices is running in a certain version or something like that. And so we had some ideas of how to do this in a swarm or distributed fashion, using the testbed as an example. So if one device is already attested, it can serve as a verifier for the other devices. And also we discussed ideas to combine some drafts, because attestation is an existing draft, Lake RA, that runs on top of ad hoc for ad hoc attestation, but we also have a Lake Auths that allows authorization. So we had the discussions on how to combine all these flows into a single one to be more efficient and use less bytes over the wire and less messages as well. And finally, we have some work on developing a cryptographic abstraction layer. So this is an effort that we are working in collaboration also with the team with Aerial OS. And we also want to attract more people if they are interested in this, because we want this to be really generic, not only for Lakers, which is our use case right now, but we are really interested in having this maybe becoming a big project that can be used for more people, because it's a problem that we find every time we try to find something to some library to use the available cryptographic accelerator. We have to write it by ourselves. So maybe this can be a common effort. So the goal in the hackathon was to run a public key accelerator in this STM32 chip. And we were able to execute the modular addition and subtraction. And then the multiplication and exponentiation is ongoing. And of course, the credit for this work is with Elsa, which is on the lake table. And the previous work on the remote attestation is with Yushuan. And I was mainly working on the Blink part. That's it. Thank you.
Okay. How's the right? Yeah, this is the RPP, revision 2, and then next is the secure hybrid network presentation. Yeah.
Hi, I'm Paul Kwalik. Together with Martin, Vincent, and Christian, we're working on RPP, RESTful Provisioning Protocol. So what is RPP? It's an alternative protocol we are developing to, let's say, alternative to EPP, Extensible Provisioning Protocol, which is mainly used for provisioning of domain names by domain name registries. We want to base the protocol on RESTful principles with HTTP and JSON payloads. So talking about the RPP, we are thinking about different deployment models. So one is basically deploying RPP parallel to EPP to the registry, but also we can envision the deployment models where RPP will be in front of EPP or opposite. And this led us actually to our Hackathon project, which we thought to start with this approach of putting RPP in front of EPP. So basically we can validate the functional parity of the current implementation, current registry functions of the new protocol, and then extend it from there. So basically, on one side, we developed the specification of the RPP and using the type spec, and we generated OpenAPI out of it. And this we put into RPP proxy server. We developed a client and let's say mocked EPP server, which will emulate the whole flow. So basically, as a result, we have for one use case of domain creation, the full end-to-end flow from the client to our EPP server and the response back. So basically, this working for this use case from the result of the project. There are GitHub links to the different parts that we developed and that we will probably develop further. And there are 2 drafts of RPP, which will be presented in the working group on Monday. Thank you.
Okay, thank you. Up next is the is here. The secure hybrid network. And after that is the PQ in X509 certificates. You can use the arrows for the, yeah.
Thank you. I'm Yutaka from AIST Japan. So I tell you about the recent project about the securing hybrid networks. So currently, hybrid use of clouds is now common, especially in high reliability systems which connects multiple instances of network or cloud services to compose a single system. For example, we can use on-premise system for secure data vault while using public cloud concurrently with web front end, something like that. So in such communication setting, we have provided communication by various means of interconnection paths like VPN or VLAN or overlay network or even list lines. And for system integrity, assurance of the real-world properties of such interconnection paths is very important. Like nodes on such paths are managed only by their contracted operators or something like that. So So we are developing a technology which supports the monitoring of certain characteristics of communication paths resulting from routing. So example like operator of the intermediate node or some checking phase of the connection will routed into the designated VPN or which network even the VPN traffic will flow through. And the problem now is that in such use cases, the modern internet complexity is currently addressed primarily through manual interventions like configuration put by network engineers or something like that. So they are trying their best to get the intended network, but ensuring that continuing is a different problem. So this is an example setting. So if in many cases, end user only have a contract with the next hop network operator, which might operate such as local cloud, but many internet cloud providers provides connectivity to mega clouds like Amazon, AWS, or Microsoft Azure. In that case, the connecting to the next hop is currently almost a black box situation from the side of the end user. So our goal is to check whether the connection between such network operators are secure or not. And our aim is to minimize the impact on the existing protocols, devices, and even the network deployment. So we are not changing the existing code, but we are putting some monitoring layer or monitoring system around the existing network. And we are also caring that VPNs or overlay networks are other such protocols as almost natively. And we are currently designing this kind of path-centric monitoring approach into the reality. So this is our first presentation in Hackathon, and thank you very much for Hiro. For him, he's a first IETF and first Hackathon. Welcome. And if you are interested, please see the details as submitted as an internet draft. Thank you.
Okay, up next is the post-quantum X509 presentation. And after that is the skit. All right, over here, I've seen them. The skit presentation. Yeah. Right. Like, over here, yep. There we go. Yep.
Hello, everyone. I'm John. So I get to present to you the PQNX 509 project. We've been working on this for a couple of years now. Basically, we look at doing interop testing with these new things, these PQ algorithms that are coming in X509. And you see here, there's a lot of drafts that we kind of worked on, or we try to help give guidance or interop testing with. So there's lots of things going on in this group. The important thing, what got done this time. So we've had a number of different iterations of this artifact file, where basically it's a zip file and you put your stuff in there and then other people can download it and you can test it. So now we're at version 5. And so what was added in this one is support for testing the private key formats for MLDSA and MLChem, because there's 3 different ones now. There's the seeds expanded and or both of them. Lots of discussion on that. Anyway, so that's finally being tested. Also, we have artifacts for the SLH DSA private key format. The other thing, we have a new updated format for testing CMS Chem, so that's up to version 3. And we also added support for testing the CMS signatures as well. So that's great to see. We had 6 different implementations of the MLDSA private key format being tested, so that's good to see. We also had an implementation of composite signatures 04 that was just dropped just a couple weeks ago. So the first one is there. We need other people to do that so that we can test. But at the same time, that being said, we had much discussion in the group about the private key, the key formats used in composite, and it looks like that might change a little bit. So maybe that will make version 4 a little bit obsolete. But we'll see. Okay, so then what else got done? We also have a new Rust implementations of the MLDSA, MLChem, and SLH DSA. So it's great to have more varieties of algorithms that we can test with. Also, an implementation of the chem recipient info it's being added into OpenSSL. So we had a bunch of the OpenSSL team, Tim Hudson and Victor Duchovny. They came and joined us as well. So that was great to have them. Also, OpenSSL has their own implementations of MLDSA, MLChem, and SLH DSA that they've submitted artifacts. So we're testing against those as well. So more variety again. That's great to see. And we're also adding more granularity in the compatibility matrix. So that's the thing that shows you all the test results, especially for all the different versions of the private keys. And yeah, the OpenSSL team is also working on adding, anyway, this is more for OpenSSL, but they have a supporting the newer private key format. I know I'm going to run out of time. So what we learned, a couple things. So with the using SLDH and CMS with the shake extensible output function is difficult to implement. This was feedback that we heard. The other thing with RFC 9629, we don't specify mandatory KDF. I mean, it's still implementable. It just makes it a little more difficult for some people. But that's some things that we learned. And let's see what else here. Yeah, we also recommended that the new algorithms in CMS must use signed attributes. So we had a bunch of discussion on this. I'm not going to have time to go over that in detail. And the last thing I'll mention is, yeah, we're working remotely with 12-hour time zone changes is very difficult. So this is just the summary. We've had lots of team members. Jean-Pierre, Fizet, Victor, and Tim were newcomers this time. We're going to continue. Our monthly meetings are on the first Tuesday of every month. So April 1st is our next one. And yeah, we're going to continue. So come join us. This is pictures from the past. I didn't get any this time yet. So thank you.
Yeah, so I want to thank all the speakers for we're doing very good time-wise. So I'd like to thank all the speakers for staying within the allocated time slot. Up next is the SCID presentation, and then we have the post-quantum cryptography for DNSSEC presentation.
Okay, so we have two projects and we have two speakers. Interesting overlap here between us and the, thank you. Us and the Ops Area Working Group Data Provenance Project. So definitely food for thought there, and we should catch up during the week. So two projects, one based on an adopted document for a reference API, getting running code working, and another on the compatibility and appropriateness of the architecture document for Yang modeling and use of provenance there. So for Scrappy, again, interesting comparison with the Ops Area Working Group. We are all about CBOR and COSI and not about JSON REST. So we've got a good opportunity to collaborate there. So we already got to a point where this was all working. So between IETF 121 and 122, we've made it much more sort of simple and trying to optimize things at a protocol layer. And we wanted to see whether that was actually practical to implement for real world people, bearing in mind we're trying to make this thing accessible and make COSI and CBOR actually used by people in the real world. It's got to work with stuff that people use. So why is this a complex problem? We're dealing with eventually consistent data structures. They can live all over the world. They get consolidated. Their identities change. They might get sharded to a different part of a database. And so it's very difficult to come up with a consistent way of having something which is a consistent object this second and also in 7 years, and you can still find it and verify it cryptographically and completely. So we had a couple of areas in the protocol that really need to be absolutely rock solid so that if I look for something and it's moved, I can still get it back and I know it hasn't been tampered with or replaced, and I need to do that in code that runs and works. So essentially, it works. So we've massively simplified the model. We've reduced complexity in the back end. We've made it easier to implement transparency services in this way, and also written a Python SDK, which is like 1 or 2 lines, and you can actually interact with this thing. So again, making it much easier to adopt. We've done it in line with CBOR2 and PyCozy, so standard libraries, and we've published all our stuff here. So if you want to check out the docs and those links, you can do that. I've said all this already. Okay.
And we hope to see further growth in Skit, which is maturing. We have looked for issues that will encourage further evaluation of Skit is in supply chain security. And the specifications we focus on are 3. And RFCs from the officers and the WASD items for Skit. We identified issues and triaged them and organized the key point for saving them. We focus on young modeling of a set of statements that match the Skit architecture and future Skit support for dynamic statement lifecycles. And this activity is not yet complete, and the remaining issue we have discovered will be carry over to the Madrid Hackathon. However, it is good for us. We focus one of the issues to work on at the hackathon in Madrid. We have obtained the report contents on the result of the Skit working group. The Skit working group item is wide range and flexible. So it is not easy to make a new draft. So next, so break down the solutions we have identified, and it is also essential to compare technology for implementation and specification writing. Finally, a draft and media will be created to report.
Yeah, thank you. So if you want to know more, we'll be working on this on Thursday in our working group meeting, and please do come along and discuss these issues in more depth. Thank you.
So up next is the post-quantum cryptography for DNSSEC. And after that, we will have the presentation on transforming network data to RDF.
So hi, this is Henri. So the DNS hackathon is distributed as DNS itself. So there are actually more people working on post-quantum cryptography. So this is just a teaser. I've implemented a couple of new algorithms. For those who do not know these people, this is new kids on the block. And so these are the algorithms that are being now submitted to an additional call for the signatures. I have all of them implemented. Some of those doesn't work yet because the upstream implementation is broken. And you can see more during the post-quantum DNSSEC research site meeting on Tuesday morning. Thank you.
Okay, I think the next presentation is remote. Is that correct?
Yes.
Excellent.
Can you hear me okay?
Yeah, I will bring up the slides and hand over control to you.
Thank you.
Yeah, this one. And you have control. Yeah.
Great, thank you very much. Hi, everybody. This is a project we did based on something we did in the previous Dublin work, where we were doing mapping from Yang to RDF, so mapping the language, the Yang language and the Yang schemas to RDF. In this case, though, we were mapping the configuration. So what's RDF? RDF is a graph language or a graph format defined by the W3C for graph data using triples, subject, predicate, and object. Everybody here knows about Yang. So in this particular approach, we had a go at doing it using RML, which is also a mapping language defined by the W3C. Here you can see the format of it. It's declarative, which has issues in and of itself. So we'll talk about that in a second, but this is maybe just a quick example of what it looks like. This is the format of the of what we were doing. So we were taking configuration data in. We were using an RML processor. That RML processor is using an RML mapping, declarative mapping, which would then generate some RDF data. And then we were using Sparkle, which is the query language defined for RDF, to refer back to the Yang schema stuff we did in Dublin. So we were pushing the data into a named graph. So each set of config would have its own named graph. Obviously, as I mentioned, we will create triples. What does that look like? Well, here is a small number of triples that are just associated with a single interface on a network device. You can then query on that here. So let's say you wanted to simply just get all of the information related to broadcast interface. It looks a little bit nicer. However, this approach didn't prove to be great. It's the declarative mapping is not really suitable. The RML tools that we're using aren't that great either. So we think in Madrid we're going to do an approach that maybe combines this approach with maybe a stream based approach and to do it all in memory. So yeah, on to Madrid. Thanks everybody.
So thank you. I have two presentations queued. So the next one is the identity crisis for attested TLS. And the last one is testing congestion control and queue management. So if your presentation is not mentioned or you haven't presented yet, come over to us, then we miss your presentation. So, yeah. All right, so first we go to the identity crisis. Oh, I just see a new one coming in. Yeah, thanks. So next up is identity crisis.
Okay, so I'm Sama from TU Dresden, and I want to thank GenXT for providing me the travel funds. The idea of, or the plan for the hackathon was to find some solution to the problem which is on this slide. Basically, it's a redirection attack in confidential computing where we have CSP controlling all of the domain, and it can redirect to any machine that it wants within the threat model of confidential computing. And the machine 1 is a good one. Machine 2 on the right, CPU 2 is a bad one. What the adversary does is simply redirects the connection to the second machine, and then from that it has already compromised, and with that it can provide the proof of attestation. So the core idea is, like, after redirection it generates an evidence with that key which has been compromised. Step number 3, it sends back the VM the evidence, and then step number 4, it conveys the evidence not with the measurements of the machine that it has compromised, but with the machine M1 that the original client wanted. And then in that final step, it will appraise, and it has, the client has the, on the top shown the trust store, it has the key, attestation key 2 also in its trust store. Definitely it will accept the evidence. So the involved IDs are a couple of IDs written at the bottom of the slide. Both of them failed to protect against this attack. The idea of the hackathon was to discuss around, rather than doing the code we already have done, we have a formal proof that this attack holds there for the first draft at least, not for the second one. It's a 0.0 draft that we just launched this time. So the idea was to, first I want to thank all the participants which participated in the discussions. We had very good discussions. And as I mentioned already, we found no solution for the attack so far. If you have any clue or any guess, so we discussed all around from transparency logs up to everything what is done inside the attestation key generation function. So nothing helps. So if you have any clue how this can be solved, you are very welcome to discuss. I'm here around for the whole week. And one thing that I want to emphasize is that in the protocols, RAT's remote attestation is thought of as just sprinkle this sauce and this will give you very good security by out of a magic. That doesn't hold. So it can even weaken your protocols if you put in remote attestation. It can even lead to lesser security than you would have without attestation. So the next steps are, we will discuss this in the TLS working group as well as the Whimsy working group, the relevant parts, identity parts, of course, in Whimsy, and the TLS protocol related parts in TLS working group. There are a couple of side meetings where we will discuss some basics in the first meetings, the fundamentals, and then the deep formal details of how the attack happens. And we would like to discuss what the potential solutions are. We have like partial solutions, of course, but there is no complete solution that we have so far. And of course, in the hack demo, we will also present. And finally, I have a few pointers to where you can look into the details of. Particularly, I would like to describe the wiki page has a reference to the, and also the TLS working group. I posted the problem already. So please have a look. And if you have any ideas on how this can be solved, or something you feel is not yet in the model, or something is not understandable, of course, it was at very abstract level in the TLS working group presentation. But of course, if you have any follow-up, please talk to us. Thanks.
Okay, then. So up next is the testing congestion control and queue management. And the last presentation for today will be the HTTPS notif draft. Right. Okay, come on. And you can use the arrows.
Sure. Hello, everyone. I'm Mahati, and this is my team, Shriya, Preeti, Suprada, and Anuhya. And we are undergrad students from NITK, and this is our first IETF. So in the hackathon, we mainly worked on testing congestion control and queue management mechanisms. So what was our plan and what we achieved? So we set up experiments using NS3 and CCPerf. CCPerf is an NS3-based framework for testing congestion control algorithms. And we mainly performed experiments with AQMs, queue management algorithms, two of them. Firstly, FQ-Codel, which is already in RFC, and FQPy, which is an internet draft in TSVG working group currently. Both these objectives, we were able to complete this in the hackathon. Testing the growth of congestion window with and without rate-limited increase. This is yet to be done. We plan on doing this week, as well as testing it with CCPerf as well. And implementation of a modified codal mechanism. This was also completed by a remote participant. So yeah, so these were the list of experiments that we performed with the help of CCPerf. This was basically evaluating the network performance under various network conditions. I will be sharing the results and observations we obtained with one of the experiments, that is response to pulse width. So what was the experiment? We oscillated the network bandwidth between 16 Mbps and 32 Mbps, and we obtained the results using two AQMs. So this was the result for FQ Codal. We observed that while we oscillate the network bandwidth, using FQ Codal, the throughput kind of cannot keep up with the oscillating bandwidth. Even though we have 32 Mbps, the throughput kind of remains stagnant around 16, which was interesting because with FQPy, we observed that the throughput does keep up with the oscillating network bandwidth. It makes use of all the available capacity, and we get a throughput of up to 32 Mbps. So we have a lot more observations and analysis, so do reach us out. And for more details about FQPy internet draft, do join us at TSVWG working group on Wednesday. Yeah, that's it from our side. Thank you.
Excellent. So, and for today, the last presentation will be the HTTPS notice draft presentation. Yep. Okay, you can choose that.
Okay.
Yeah.
Yeah. Hi, everyone. Today is what we did over the last 48 hours or so is we were working on the HTTPS-based transport for Yang notifications draft by Mahesh and Kent. And what we specifically worked on is the integrating Kafka into the whole procedure, performing some bandwidth analysis for different encodings. So right now, the draft by Mahesh and Kent supports JSON and XML as encoding options. And they suggested that we could also incorporate CBOR into the same thing. So we did that and wrote our own draft from Kent's and Mahesh's suggestion. And basically what we've completed as of now is adding CBOR support to the existing draft, which initially supports only JSON XML. And we managed to perform some bandwidth analysis. And the code's on GitHub. Feel free to go to repo. Small aside is that we are following RFC 8343 for the notification data. So what data is being sent over HTTPS is conforming interface configuration RFC 8343. To talk about bandwidth, I'll give it to Meher.
Right. So we perform bandwidth analysis on different encodings, and for that we've set up virtual network namespaces where we're running the publisher on one namespace and the collector on another, which is connected through links. And how we're doing the bandwidth limiting is using TBF QDisks with certain configurations. And here are the results we got for JSON and XML. So the blue color is JSON and orange is XML, and we see that JSON XML have similar performance and extremely low bandwidths, so the throughput is fine. So it wouldn't matter which encoding you're using when your bandwidth is low, but as you keep increasing your bandwidth, JSON sort of outperforms XML because it is smaller in size and it's easier to send out the data. We also tried integrating the CBOR implementation and doing the analysis. We sort of observed that CBOR is having lesser throughput than expected, but we were trying to debug through the reasoning of why this was happening, and we believe there's not enough direct tooling for CBOR Yang validation. So what we do is we convert CBOR to JSON before that, and that could be an overhead step, which we're trying to debug right now. We'll either contribute directly to the tooling to see why this is the case. Now I'll call Vetka to talk about Kafka integration.
So to store the relay notifications itself, we integrate the collector with Kafka and a TSDB. We're following a similar architecture to YangPush. So what happens is once the collector receives the relay notifications, it sends it to the Kafka bus, and there's a Kafka consumer running parallelly, which sends it to a TSDB. In our implementation, we've used InfluxDB for the TSDB. That's pretty much it. Thank you to the team, and also special thanks to Mohit, Mahesh, and Kent. Thank you.
Thank you all. This was the last presentation. Did I miss someone? No? Okay, thank you all. So it comes to a wrap. And before we close, there we are. So before I close, I first like to thank all the presenters. A big hand for them. Thank you. For the presentation of the projects. First of all, some of the presenters already mentioned it. Tomorrow evening, we do have the Hack Demo Happy Hour. Saturday, I said it was at 7, but I was corrected. So it starts at 6:30 to 7:30. It's here in the lobby on the 5th floor. So please put your name on the list to present your project tomorrow. It's a good opportunity to show your results to the IETF larger community. So by all means. And it's also good conversations, and there's some snacks and some drinks also over there. And I think for drinks you have to pay, but alcoholic drinks you have to pay. But it's I can recommend it, really. It's a good opportunity. For the rest of the week, you can work, of course, in the Code Lounge. That's on the 4th floor in the Pavilion 1 and 2. And you can collaborate with other friends, hackathon colleagues, and reserve some time at the schedule. So you can find this information on the wiki, also the IETF wiki, and you can put your name and so you can coordinate some time to work on your project. Yeah, and finally, before closing, I would like to thank the sponsors. Ericsson, the gold sponsor, and bronze, CNIC and ICANN. They are the sponsors for running code. They all supporting the hackathon weekend, the food, the room, etc. So again, thanks to the sponsors for the hackathon. So have a nice week. I think the IETF hackathon is a great start of the week with all the conversations and some coding, interop testing. Enjoy the week in Bangkok. And if you have any questions, suggestions to improve the hackathon weekend, send email to the mailing list or reach out to Charles or myself or Barry. I was over there. Well, Barry. Oh, there, Barry in the back of the room. We're always open for suggestions for improvement. Thank you. Thank you.